Hello friends, this is 𝗳𝗧 I am studying 10th class in 𝗵𝗵𝗀𝗀 Girls. So before going to start a class, let me show you something. What do you observe in this picture? Yes, a group of people are gathered here. Actually, the group of students are gathered here for assembly. In our school, we also do that. After completion of assembly, all the students are dispersed into their classes, which means they are splitting up. Can you guess our topic name? What we are going to discuss? Yes, dispersion of light and a natural rainbow formation. So before going to take a class, let me ask you a question. What are in my both hands? Yes, this is a glass slab and this is a cardboard. What happened when the light incident on both these different material objects? Light behaves in different ways on both the surfaces. Let's see. So, when a light incident on this surface, what will you observe? It passes through this, which means it allows the light. And when light incident on another surface, what will you observe? It cannot pass through this, which means it does not allow the light. So, on the basis of this, the amount of light passing through a material, those are classified into three groups. They are transparent materials, translucent materials, and opaque materials. The first one is transparent materials. Materials which allow the light to pass through them are called transparent materials. One can easily see the objects on other side of a transparent materials. Some of the examples are water, glass, air, etc. And the second one is translucent materials. Materials which cannot allow the light to pass through them completely but only partially. Some of the examples are frosted glass, oiled paper, food oil, etc. And the third one is opaque materials. Materials which cannot allow the light to pass through them at all. Some of the examples are wood, iron, aluminium, wall, etc. Now, what do you observe in this picture? Yes, a prism. A prism is a transparent medium which separates the surrounding mediums and having a two plane surfaces which are inclined at a certain angle in such a way that the light incident on one of the plane surface and emergent from another plane surface. To understand the behavior of light when it is incident on a plane of a prism and passes through this, consider a triangular glass prism which having a two triangular bases and three rectangular lateral surfaces. Here we can observe a two triangular bases and three rectangular lateral surfaces, and these two rectangular lateral surfaces are inclined to each other. So, when a narrow beam of sunlight, usually called white light, is incident on a plane of a prism, here what will you observe? Yes, the white light splitting into 7 colors. So, these 7 colors appears in the sequence or violet, indigo, blue, green, yellow, orange, red, or simply we can call 𝗵𝗫𝗀 colors. So, the process of white light splitting into 7 colors is called dispersion process. What is dispersion? The process of white light splitting into 7 colors is called dispersion, and the pattern of these component colors is called spectrum of colors. So, here the question rises, why a white light splitting into 7 colors when it is passing through a prism? Let's see. We know that the visible light is an electromagnetic wave. If you throw a stone into a still pond, you will observe ripples which are transmitting the disturbances in the form of wave on the surface of the water. So, we know that the sound waves are produced when something vibrates like a drum. In the same way, the electromagnetic wave was produced when an electric charge vibrates. And the vibrating of electric charge can create a change in the electric field. And a change in the electric field can create a change in the magnetic field. So, this process continues with both the created fields or being perpendicular to each other and at a right angle to the direction of the propagation of the wave. The speed of the light in vacuum is constant for all colors. The speed of the light in vacuum is constant for all colors, but the speed of the light in media depends on its wavelength. So, the electromagnetic wave traveling through a vacuum behaves like a ocean wave traveling through a water. Same like ocean wave, the electromagnetic wave was characterized by wavelength and frequency. The wavelength of the wave is the distance from one wave peak to the next. What is wavelength? The distance from one wave peak to the next. And the frequency of the wave is simply the number of wave peaks or leaving the given point per second. What is frequency? Yes, it is the number of wave peaks or leaving the given point per unit time. It depends on the wavelength of the light when it is passing through a media. So, the relation between wavelength and frequency is wavelength is inversely proportional to the frequency, or the speed of the wave is equal to the wavelength and frequency. It is the universal relationship and applies to all the waves. As the frequency increases, the wavelength becomes smaller. So, we know that the refractive index is the ratio of speed of the light in vacuum and speed of the light in media. So, from this equation, we can say that the refractive index depends on the speed of the light. We know that the speed depends on wavelength of the light. Consequently, the refractive index of the media depends on the wavelength of the light. So, from this we can say that both speed and refractive index depends on the wavelength of the light. But here we notice that the light has chosen a different path. According to the Fermat's principle, the light ray selects its path which takes least time to travel. What is Fermat's principle? The light ray selects its path which takes least time to travel. So, here let me show you one thing. So, here see. So, from this activity, we can see a clear path of the light. So, a light ray always chooses a straight line to travel. So, when a light ray traveling through a prism, it splits into 7 colors and each color selects its least time path, and we have refraction of different colors to the different extenses. This is the result of separation of colors and producing a new spectrum of visible light. We know that the frequency is inversely proportional to the wavelength, or as the frequency increases, the wavelength becomes smaller. If we compare the wavelength in 7 colors in 𝗲𝗓, the red color has the longest wavelength and the violet color has the shortest wavelength. Because the refractive index of the red is low, hence it suffers slow deviation. The refractive index of the violet is high, hence it suffers more. So by this we can say that the red light travels faster than a violet light in a glass prism. So we can say that when a white light passing through a prism, it splits into 7 colors. Then if we send a single color through a prism, does it split into more colors? Let's find out. So frequency. The frequency of the light is property of the source and it is equal to the number of the waves leaving the source per second. This we know already. So it cannot change in any media. Hence frequency does not change due to refraction. So when a colored light passing through any transparent medium, it retains its color. Let's see. When a colored light passing through a prism, passing through any transparent medium, it retains its color. So, can you give an example in nature where we observe colors as we seen in the prism? Yes, we will observe colors on CDs. Here we can observe a multiple colors on CDs, right? So we will observe colors on CDs, soap bubbles, oil floating on the water or petrol flowing on the water, plastic scale, rainbow, etc. So we are going to discuss about a natural rainbow formation. So the rainbow is the best example of dispersion of sunlight by the many water droplets present in the atmosphere. This is the phenomenon due to combined effect of dispersion, refraction and reflection of the sunlight by the spherical water droplets of rain. Now, we already know about what is dispersion. What is dispersion? The white light splitting into 7 colors is called dispersion process. So now let's see what is reflection. Reflection is nothing but rebouncing back of light into same media is called reflection. So for example, this is your ball. When I hit your ball on the ground, what will you observe? Yes, it is again rebounces. In the same way, when a light ray falls on opaque material, it again reflects back into the same media. So here we will observe that the angle between the incident ray and the normal is called angle of incidence, and the angle between the reflected ray and the normal is called angle of reflection. So this is all about the reflection process. What is reflection? The process of the light ray again reflects back into the same media. So this is called reflection process. Now let's see what is refraction. Refraction is nothing but it is the phenomenon of changing the direction of the light at interface which divides two medias. For example, if we have here two medias, media 1 and media 2, when a light ray travelling from one media to another media, it changes its direction at the interface. So this is called the refraction process. In this process, we will observe that the angle between the incident ray and the normal is called angle of incidence, and the angle between the normal and refracted ray is called angle of refraction. So this is called a refraction process. When a light ray travelling from rarer medium to denser medium, after the refraction, the refracted ray move towards to the normal. So here we can observe that the angle of incidence is greater than the angle of refraction. So, let's see another example. When a light ray traveling from denser medium to rarer medium, after the refraction, the refracted ray move away from the normal. So, here we can observe that the angle of incident is less than the angle of refraction. So, when a light ray traveling from denser medium to rarer medium, after the refraction, if the refracted ray coincident with the interface, then it is said to be a critical angle. What is a critical angle? After the refraction, if the refracted ray interface with coincidence, then it is called a critical angle. Now, if the angle of incident is greater than the critical angle, then the light ray cannot go into the other media. It again reflects back into the same media. So, this phenomenon is called total internal reflection. Now, let's come back to the topic. The rays from the sunlight enters the drop near its top surface. At this first refraction, the white light is dispersed into spectrum of colors. Here, the violet deviated most and the red was least. Reaching the opposite side of the drop, each color is again reflected back into the drop. So, we know that because of total internal reflection. Arriving at the surface of the drop, each color is again refracted back into the air. So, at this second refraction, we will observe that the angle between the red and violet ore further increases when it is compared to those at first refraction. So, the incoming rays and the outgoing rays can be anything between the 0 degrees to 42 degrees. How many degrees? 0 to 42 degrees. So, although each drop disperses a full spectrum of colors, an observer is in a position can see only a single color from any one drop depending upon its position. For example, if a violet light from a drop reaches the eye of an observer, then the red light from the same drop doesn't reach the eye of an observer. It goes elsewhere, possibly downwards or upwards of the observer eye. So, to see red light, he must see the drop higher than in the sky. So, the red light emerges at an angle of 40 degrees. The red light emerges at an angle of 42 degrees and the white light emerges at an angle of 40 degrees. So, if we observe between these two values, I mean 40 degrees to 42 degrees, we will observe remaining colors of the rainbow. So, then a rainbow is formed. Generally, how many colors present in a rainbow? Yes, there are 7 colors present in a rainbow. We all know that. Generally, in a rainbow, top portion contains red color and the down portion contains violet color. This is called a primary rainbow. Have you ever seen reverse order of these colors? I mean, top portion contains violet color and the down portion contains red color. If that will happen, what we call it? Let's see. The first one is primary rainbow. What is a primary rainbow? In primary rainbow, we see that red light from the drop 1 and the violet light from the second drop reaches the eye of an observer. The violet light from the drop 1 and the red light from the drop 2 directs at level above or below the observer eye. So, an observer can see a rainbow contains top portion red color and the down portion violet color. The process of primary rainbow is due to 3 steps process, that is refraction, reflection and refraction. So, once again we will see again primary rainbow. Primary rainbow, we see that red light from the drop 1 and the violet light from the drop 2 reaches the eye of an observer eye. The violet light from the drop 1 and the red light from the drop 2 directs its level above or below the observer eye. So, now we can clear about the primary rainbow. The process of primary rainbow is due to 3 steps process, that is refraction, reflection and refraction. Then a primary rainbow is formed. Now let's see about secondary rainbow. What is a secondary rainbow? The light ray undergoes 2 internal reflections instead of 1 as in the primary rainbow. Then a secondary rainbow is formed. In secondary rainbow, we see that the red light from the drop 1 and the violet light from the drop 2 directs at level above or below the observer eye. The violet light from the drop 1 and the red light from the drop 2 reaches the eye of an observer. So, he can see that rainbow contains, we know that, top portion violet color and the down portion red color. Then a secondary rainbow is formed. The violet light emerges at an angle of 53 degrees and the red light emerges at an angle of 50 degrees. The intensity of light is reduced at the second internal reflection. So, the secondary rainbow is lower brightness than the primary rainbow. So, the process of secondary rainbow is due to 4 steps process, that is 2 refractions and 2 internal reflections. So, this is all about primary rainbow and secondary rainbow. The primary rainbow is due to 3 steps process, refraction, reflection and refraction. The secondary rainbow is due to 4 steps process, that is 2 refractions and 2 internal reflections. Now, let's go to another topic. What is the shape of a rainbow? Yes, it appears in a bow in shape, but the rainbow we see is actually not a 2-dimensional arc as it appears to us. The rainbow we see is actually a full circles, but many people oversee only a arc or in semicircle of a rainbow because they are standing on the ground and other half cut off by the horizon. Then he can able to see an arc or in semicircle of a rainbow. If you observe a rainbow from an aeroplane, you will observe a full circle of a rainbow. So, to order to see the rainbow from the ground, in the sky, the sun should be at the backward of the observer and the rain should be at the in front of the observer. Then he can able to see a bright colorful rainbow. So, this is all about today's class, dispersion of light and a natural rainbow formation. I hope you understood, guys. So, from this class we learned that according to the Fermat's principle, the light ray selects its path which takes least time to travel. So, a light ray always chooses a straight line to travel. We already know that. So, the reflection process is nothing but rebouncing back of light into same media. This is called reflection process. Now, let's see what is refraction. Refraction is nothing but it is the phenomenon of changing the direction of light at interface which divides 2 medias. So, this is called refraction process. What is total internal reflection? If the angle of incident is greater than the critical angle, then the light ray cannot pass into the another media. It again reflects back into the same media. So, this is called total internal reflection. The light ray, when it passes through a prism, it splits into 7 colors. So, the process of white light splitting into 7 colors is called dispersion. The rainbow is the best example of dispersion of sunlight by the many water droplets of the rainbow. So, thank you for giving this a wonderful opportunity to me. I am heartily saying my thanks to my mentor ma'am V. Sunita madam and principal sir M. 𝗵𝗍𝗪 sir and secretary sir Ronald Rose sir. So, thank you for giving this a wonderful opportunity to me.